been the administrator of NASA for like 7 years now.
Almost 7 years.
Yeah.
It'll be 7 years in July.
So, what would you call your biggest achievements so
Oh,
far?
I don't think about biggest achievements. I'm very, very happy with where the agency is and the things that we've accomplished, whether it's landing a rover on Mars, Curiosity, or for the first time ever flying by Pluto, a close flyby of Pluto, which completed the accomplishment that no other nation has done, which is to actually fly to or around or by every single planet in the solar system. We've also visited the two largest asteroids in our solar system with one spacecraft, so that was pretty unique. We have a spacecraft called Dawn that's visited now Ceres and Vesta, two giant asteroids. And then very, very happy about where we are with aeronautics, which is an area that people don't normally hear NASA talk about. And it's working with our industry and commercial aviation companies and academia actually to produce cleaner, more efficient, faster aircraft and the like. But then coming back to this conference, having an opportunity to really focus on our Earth, what I call the most important planet, and spend a lot of time with our partners trying to figure out what we can do to arrest the changing climate, to try to turn things around, and if we can't do that, at least stop the degradation that's going on right now, like losing the glaciers and watching the oceans rise and things of that nature.
NASA's 2017 budget
Yes.
demands there is remote sensing figures as one of the top things.
That's correct.
Could you elaborate on?
The reason that we think, I mentioned the fact that Earth is the most important planet. We can't do anything in terms of exploration if we don't have Earth as our dominant platform from which to leave. So it's really important. What we're trying to do is actually get the level of funding for Earth science back to its historic level. We've really gone down in funding for Earth science over the last decade or so. And so President Obama has helped us to propose more funding for Earth science so that we restore the balance that we once had in that particular area.
By that, do you mean it has been more towards deep space missions and less towards Earth science?
Absolutely. In fact, more toward, and I wouldn't say it's more, but the balance was much more toward human spaceflight endeavors. The Constellation program over a number of years, phasing out the shuttle. So we had major programs going on simultaneously, the Shuttle, International Space Station, Constellation, and that took a lot of the funds that normally would have been spread across the agency in a little bit more balanced way. So we're restoring the balance that we feel is adequate. We have a robust human spaceflight program because we now are relying on our industrial partners to provide routine transportation to and from space to low Earth orbit. We have orbital ATK and SpaceX providing cargo transportation, and in a couple of years we'll add a third company that's called Sierra Nevada. They bring a different type of vehicle. They're actually bringing in a winged vehicle that looks like a miniature shuttle. And then in human space flight, we're going to have Boeing and SpaceX provide two crew vehicles so that we're no longer reliant on the Russians. And those two vehicles, Boeing has what's called the CST-100, their Starliner, and SpaceX has what they call the Crew Dragon. So we're going to fly the initial test flights on those and certification beginning next year. So in 2 years, we hope to be flying from American soil again with our astronauts and the astronauts from our partner nations. I'm actually here for the Remote Sensing Symposium that's going on this week, and for me it's an excellent opportunity to get a chance to do things that NASA does that we don't normally talk about as much in public as we do human spaceflight. NASA is divided into 4 big areas: human spaceflight, science, and science is subdivided into 4 areas. So we're focused on one of those areas in this conference, which is Earth science. And it gives us an opportunity to come together with representatives from other space agencies around the world to talk about things that are common to all of us, the challenge of changing climate and the challenge of natural disasters. So it gives us an opportunity to talk about how we can collaborate better, make sure that there's synergy among our programs so that we're not duplicating and everything.
You talked about this next generation successor to Hubble.
Yes.
It sounded, it was sounded very interesting
It's
project. Could
very,
you
very,
just
very interesting. And that's the James Webb Space Telescope. And James Webb actually is from a totally different area of the science portfolio than, say, the remote sensing we're talking about. James Webb is sort of a cross between a planetary science mission and an astrophysics mission, and more astrophysics than anything, because James Webb is going to allow us to see about 100 times better and farther than the Hubble Space Telescope. And if you remember, Hubble revolutionized our understanding of the universe. James Webb is going to allow us to look into the atmospheres of some of these planets that we've discovered recently that we call exoplanets. Planets orbiting other suns in other galaxies, way away from our own galaxy. I mean, many thousands of light years away. And James Webb actually has the ability to be able to look into those galaxies and into the atmosphere of some of those planets. So we're going to learn a lot more about a lot of other planets that are around other suns. So that's what's so spectacular about James Webb.
So when is it expected, and when is it expected to like go functional? Like when can we expect the
We're
results?
scheduled to launch in October of 2018. And you probably remember in my comments I kept talking about the critical importance of international collaboration. James Webb is a partnership among the US, Canada, the European Space Agency. We're actually going to launch on an ESA spacecraft out of Kourou down in South America. It'll be on an Ariane 5. So we have real critical partnerships. When you look at our exploration program, the Orion spacecraft that's going to be used to take our crews to Mars, the service module, which is the power and propulsion part of the Orion spacecraft, is being built by our European partners. So it's actually being built in Turin, in Italy, and then shipped to the United States for integration into the rest of the stack.
What are some of like NASA's collaborative efforts?
If you look just at ISRO, for example, NASA has had a strong partnership with ISRO for a number of years. That partnership is increasing in both its seriousness and its intensity. We are very proud about helping ISRO in their successful flight of MOM, the Mars orbiting mission. They, helping India become the first nation ever to reach Mars successfully on their first attempt. That's not a small feat. And we played a critical role in helping to do that. We provide the deep space communications and navigation, and every once in a while, like right now, we're comparing the data that's coming from the MOM mission with data that's coming from our MAVEN mission, both of whom entered orbit around Mars within days of each other. We're right now looking at a synthetic aperture radar that looks in two, I use the term bands, frequency bands. So we're producing an L-band radar that enables us to see Earth shifting. So what we're talking about is trying to help us understand earthquakes. So we're really looking forward to that mission. That'll launch sometime in 2020 or 2021, and that's in partnership with ISRO. So there are a number of different projects that we're working with ISRO to expand on the projects that we've done in the past. 120 nations with whom we have formal agreements, and the partnerships are anywhere from something as basic as STEM education all the way up to something as elaborate as the, astrophysics and the International Space Station, which is human spaceflight. The International Space Station, there have been about 80 countries that have actually participated on station. The thing I love about the International Space Station is it's a conglomerate, if you will, of 5 agencies from around the world: the Russian Space Agency, NASA representing America, the JAXA representing Japan, Canadian Space Agency, and who did I forget? ESA. No, I got ESA, so I think I got them all 5. But that is an incredible venture, if you will, considering the fact that we have been continuously occupying the International Space Station now we're in our 16th year. There's not been a second when there haven't been human beings operating, living and working on the International Space Station, usually for about a 6-month period of time. Normal crew is 6, that we rotate 3 of them, every 3 months, another 3 come up. We're about to stretch the number of people that we have on board when we get our own American-built vehicles, because we'll be able to send an extra crew member. So we'll get more productivity, much more utilization out of the International Space Station. It's exciting, the international partnerships that we have. I think what you heard from all of us, from all of the international partners, is the fact that there is no better platform to observe our planet than space. And in order to do that, you need a satellite that's, that allows you to put various instruments on board so that you can do the remote sensing that gives you the kind of data that, that your magazine and your organization focuses on, what we call geospatial data, whether it's looking at weather, or whether it's looking at land changes in the land, forest, oceans. That's all considered to be data in a geospatial realm, and so that's what this conference was all about. And the big thing is to help people understand how we cannot understand our planet, we cannot tackle the challenge of changing climate or environmental changes, and we can't deal with natural disasters if we don't have the vantage point of space to observe Earth. It gives you an opportunity for repeated visits over the same area of the globe. Frequently, you get 3 looks every day at a particular area that may be in crisis because of a flood or a hurricane or a typhoon or monsoons. Nowadays, we are good enough with meteorology, the meteorological satellites, that the weatherman can actually forecast when floods are going to come. So you look at an area like Bangladesh, we've been told that thanks to some of the international satellites that we had, the Bangladeshi government was able to evacuate people along the river last year and probably save thousands of lives by use of that capability.
Should governments be encouraging uptake of spatial technologies and data in their work processes in governance?
Government's role is to blaze the trail, to do the things that private entities, academia cannot do. So we try to develop instruments that have not been developed before, that people have thought about, but nobody, wanted to make the investment because of the risk involved. That's what government should do.